Oh, hello. This is Matt, who created the language, and I started everything. And usually, in the keynote in the conference, I usually talk about the community and the philosophy and something. But this one is kind of exceptional. So this one is quite technical. So are you ready? Okay. The Ruby language I created it in 1993, which is 26. Thank you for calculation. I'm very bad at math. Everyone claims Ruby is good. Ruby is good because with the programming in it is pretty productive. And the programming in Ruby is flexible due to the very concise the programs, or maybe from the meta programming. And also, the programming in Ruby is fun for most of us. But the programming itself is quite fun. So I'm pretty big fan of programming since I was 15. But back in time, it was early 80s. Then the only programming language I could use was the BASIC, which is kind of poor back then. And I started interested in programming language in general because of the language, the way to express our thought. So the designing a language is kind of the designing the human thought. That concept that attract me when I was a high school student. But back then, we didn't have internet in the 80s. And I couldn't learn about the computer science and how to create the programming language. And so I just gave up that idea at that time when I was 17 or 18 or something. Then I majored into, I entered into university, I majored in computer science, and I worked as a professional programmer for a while after I graduated from school. And then, yeah, I started programming Ruby to have joy. There's no pressure to create a language. I just wanted to. I just wanted to create my own programming language to design the way of thinking of programmers. But at the same time, Ruby is not the perfect language, and then some claims Ruby is bad. Ruby is bad at performance. The Ruby doesn't work well with the multi-core CPUs, and Ruby doesn't work well with the bigger team or bigger project. Yeah, that has some aspect of truth. But for the most of the case, Ruby is good enough. For the performance-wise, so the very big, so many websites and so many tools are written in Ruby, including very big sites like, say, Airbnb, or maybe some part of the Twitter or some. The Twitter story is pretty phenomenal. And in 2000, I don't remember, 7, when Twitter was started, it was a Rails application. But the Twitter architecture, which is based on the message streaming, is now very suitable for the database CRUD application, which is very suitable for Rails. But Twitter is not. So that they rewrote the new architecture, and based on the Scala programming language. So that back then, so many people claimed, okay, Twitter just gave up the Ruby, so we should, or something like that. But remember, Twitter was written in Ruby 1.8, which is very, very slow. And the Ruby 1.9 plus is far faster compared to the Ruby 1.8. Actually, the the core interpreter of the Ruby 1.8 was written by myself. And then Ruby 1.9 virtual machine is written by the smarter guy. So the big sites using Ruby, GitHub is written in Ruby on Rails, Airbnb use Ruby, and Instacart use Ruby, and the Cookpad company, which is the one of the world's biggest recipe site in Japan, is written in based on Ruby. So that even those big sites, big services can be written in Ruby, so that your service can be written in Ruby. So that means Ruby is good enough, fast enough. And in addition, the Ruby 2 improves the performance gradually. Like this graph, you can see the performance, the higher the better. The performance of the Ruby Rails bench is getting a little bit bigger each version. So that means Ruby is fast enough, and for most of the cases, and if you reach the limit, it's okay. For example, the Twitter. When Twitter started, no one understood what Twitter was. It was we called them the microblog, and the blog that limited their entry in 140 characters. This is kind of useless. This is kind of stupid idea. So that the many investors had the idea of Twitter, and that they reject it. It's silly. So that if you if you set up your WordPress site, you can write as long as you want, but Twitter just provides the limit of 140 characters. It's kind of stupid. But the Twitter people didn't give up, so that they put a microblog, then they put the search, mention, retweet, and a DM or something, and then they gradually defined what Twitter is right now. And at that stage, the being written in Ruby is pretty crucial. It is flexible, so they make it easy to change. They can experiment their new ideas. They gave us some of them. They use the many of them, so that they gradually form the idea of what Twitter is. Then Twitter became pretty popular. Then the users has grown, and then it is quite difficult to handle that kind of huge traffic, huge members, and huge data. So at that point, they started migrating the newer technology, or maybe faster technology. But that means if that kind of situation happened in your service, it is success. It is success because you have tons of data, tons of traffic, tons of users, the very big business. So you got money, so that you got money to migrate your system, your service to, say, Java technology or whatever. That's okay. So the Twitter story is actually the success story for us. We help them to try out new ideas at the very early stage. And in addition, we keep improving the language and the implementation, so that we are moving the limit even farther. So that if Twitter was developed right now, so that they didn't have to move on to the other technology. Maybe the Ruby 2 is fast enough for them. I don't know. And we are trying to improve the performance even farther in Ruby 3. And we are planning to release Ruby 3 in late next year. Yeah, just plan. So the first improvement point is the GC, garbage collectors. When I talk with the people behind the big services, especially in China, the people claiming, okay, the Ruby virtual machine is fast enough for us, but the memory bottleneck is bigger. For most of the big sites, big services, memory is the first bottleneck. So that we need to improve the garbage collector. So that we have improved the garbage collector for the last several years since Ruby 2.0 is released in 2013. The Ruby 2.1 introduced the generational garbage collector. The Ruby 2.2 introduced the incremental garbage collector. And then Ruby 2.6 released last December introduced the transient heap. And the Ruby 2.3 we are working on the object compaction in which will be released with the Ruby 2.7 this next December. So let me introduce these technologies. The generational garbage collector is the technique to improve the GC time. In general, so objects live short. So most objects created die young. So treating these new objects, newly created young objects, especially, that could reduce the garbage collection time. Then separating generation. If the object survives the one garbage collection, so that it will promote it to the older generation. So then you don't have to scan these old objects because those objects live longer than the normal objects. So but sometimes these kind of the long-lived object is filling the memory. So that we sometimes use the major or full garbage collection to collect all of data, including these older objects. So we have to maintain the remember set, which is the bookkeeping of the younger object younger object reference from the older objects. So that we need to introduce the right barrier to maintain that kind of the remember set. So the Koichi, which is in charge of the garbage collector and the virtual machine, so we implemented the Aogen GC, which is the restricted generational garbage collector, which is the Ruby garbage collector was the traditional mark and sweep garbage collector for a long time. But to make it the generational, we need to add a right barrier to every corner of the language implementation. So that it is kind of heavy burden. So that he introduced the gradual way to moving towards a generational garbage collector. So that he picked one class at a time to add the garbage collector, add the white barrier to maintain the remember set for the garbage collector. That right barrier can be used as the incremental garbage collector. Then the incremental garbage, I'm sorry. Incremental garbage collector is the stop the garbage collector in between of the marking phase, so that the garbage collector GC pass type can be split into many pieces. So that when the object is allocated so many, the garbage pass time cannot be ignored. So that when we provide the web servers, the most of the cases it's okay, but sometimes the garbage collector started, and your service will be stopped for a second or two, so that your users, the 99% of your users are okay, but the one unfortunate users who hit the garbage collector have to wait a second to show the web pages. That is not good. So that by doing that the marking phase incrementally, so the pass time will be separated in the many fraction of the execution. So we use the right barrier. Before the incremental garbage collector, the OOBGC, out of band garbage collection, is the way to reduce the pass time. The out of band GC is the call GC explicitly between the web request. So that in the idle time we call GC so that in the GC won't happen during the handling the request, the web. But after the incremental garbage collector, you don't have to use that kind of technique. For example, the GitHub used to use the out of band GC because of everyone uses GitHub, so that you don't want the very long pass time during the web page rendering in the GitHub. So that they use the out of band GC, but after Ruby 2, we introduced the incremental garbage collector. They removed the out of band GC because we don't need it. We no longer need it. The transient heap is the kind of the generation things. According to the short life hypothesis, so the most objects are young. The most objects are the most memory pages reference of the young object. Usually we use malloc to allocate the memory region for those young objects. For example, the string body from the string body reference to the string object, or array body reference from the array object. These are the allocated memory region using malloc. But the malloc is the heavyweight function, so that we want to avoid calling those functions if it's possible. So that we pre-allocated the transient heap pages at the beginning of the execution, so that allocating the memory region reference from the young object use that kind of the pre-allocated pages. And when the object survives the first garbage collection, those transient heap pages are promoted to the malloc page, so that you can reduce the invocation of the malloc function. Well, then object compaction. Free and allocating and freeing objects cause the fragmentation. So Ruby used the big page of the object, which we call the heap pages, and then we allocate the objects from these pages. But some survives, some did not. So that we have some pages only one object is alive. If you allocated so many objects in a very short amount of time, but most of them died. So that to reduce the memory, the physical memory allocated by the process, so that you want to give back these pages to the operating system. But if very short amount of objects scattered in the very sparse object heap is, so that you cannot return these pages to the operating system. So that the physical memory is consumed by these processes. To reduce that, to avoid that kind of things, the Aaron Patterson from GitHub is working on the object compaction to reduce the total memory consumption, and to reduce the cache miss. And it is the mostly moving compaction, so that you can move the object to empty the pages if possible, then return these empty pages to the operating system. And then from the patches pull request from the Aaron, it is explicit compacting. So that it's kind of like out-of-bound GC, but it is in free time we call the gc.compact to compact these pages. So that it will take a little bit amount of time so that it should be called explicitly. And memory is not the only bottleneck. We have the CPU bottleneck and the I/O bottleneck. So to resolve the CPU bottleneck, we are working on the JIT compiler, just-in-time compiler. The Ruby 2.6 introduced the MJIT. M stands for I don't know. It compiles Ruby bytecode to C, then compile C using GCC or clone, and then dynamic load the compiled object code, which is kind of insane. But it is some merits. But it is portable because the GCC is ubiquitous, and it supports so many operating systems and so many CPUs. And the JIT compiling is heavily rely on the CPU, so that supporting Intel or PowerPC or whatever is kind of burden. But by using GCC, we don't have to worry about that kind of things. And GCC is quite reliable. It has more than 20, maybe 30 years of history. And the optimization of GCC is pretty, high quality. Of course, it has the merits. It is heavy and inefficient, especially memory-wise. And we tried MZ for CPU-intensive tasks. Our benchmark is OptiCalot, which is the Nintendo Entertainment System emulator. And it is very, very, very CPU-intensive task. And Ruby 2.6 with JIT compiler runs 2.8 times faster than Ruby 2.0, which is quite nice. But unfortunately for Rails app, MJS runs slower. Yet. Probably the reason is too many methods. The Ruby on Rails has so many methods. And the compiling and then loading in the dynamic library could cause the memory bottleneck. So we are working on the smarter threshold and lighter compilation. So that a guy in Red Hat whose the real job is maintaining GCC is now working on the mill, which is the lightweight compiler, which can be compiles more lightweight in both in the time-wise and the memory-wise. So that in the future, this is the future plan, and the basic methods are executed in the virtual machine using bytecode, and then many methods which can be bottleneck can be run JIT compiled by the mill, the lightweight JIT, and a very heavyweight inner loop method can be compiled by the MJIT, which can be a highly optimized GCC compile. Yeah, this is the status of JIT. So that remember, the JIT performance is promising, but not for Rails yet. The other way to improve the performance is utilizing multi-cores. Now we have many cores in the machine. The web is a multi-core architecture, fortunately. So for example, Unicorn uses a multi-process, and the Puma uses multi-thread. And recently appeared the Falcon uses a multi-fiber to utilize improve the performance. And so the concurrency is the key to the future. Now Ruby has threads and fibers, but unfortunately we have the gel which is the global interpreter lock. That means the only one thread at a time can be executed. Because of the virtual machine has many shared status, so that running these threads without blocks will easily crash your program, or maybe introduce the deadlocks. That's not good. So that we need some new concurrency model for the future concurrency execution of the Ruby. One of them is the guild or isolate. The guild is the code name of the project, and then we were trying to name it guild, but we get the complaint from the gaming industry. We use the guild, so that we might be renaming it to isolate or whatever. So the guild is the kind of the object space which can be isolated from the other guilds, and we don't have any sharing object. The communication is done via channels. We don't have logs. We don't see deadlocks, and you can kind of think of the web workers or isolate in JavaScript. It uses multi-core for CPU-intensive tasks, and then trying to make them as lightweight as threads. The separating object space is kind of heavy burden, but we are trying to make it efficient enough. The other idea is auto fiber, or we are not fully satisfied with that name, but maybe we rename it whatever. The naming is pretty difficult in computer science. It is the kind of the thread, but context switch only happens with IO operations and with no time slicing. So that means it is far easier to maintain than threads. That is there to avoid IO blocking. So that can be used to the IO intensive task. So that we are gradually offloading the current threads in the Ruby, and then we introduce the guilds or isolate for CPU intensive task, and then you can use the auto fiber or whatever for IO intensive task. Then threads will be offset gradually. That is our attempt to improve the performance. How about bigger teams and project issue? When project started, Ruby is productive, or it's the rich features, or it's the rich set of gens, or its flexibility, like metaprogramming. But as the project grows, test becomes a burden, and test increases its size. Test issue type takes more time, and then to be honest, I hate tests. Yeah, I do write tests. Yeah, I'm not going to ignore them, but I don't like them. It's not dry. So, but we do write tests anyway. But want to be more productive. What other language try? The other language face similar issues or problems, challenges. So the PHP introduces type hinting. So the introducing static typing is much better. It's quite hard these days. The Python 3 are the type annotations. JavaScript into TypeScript, which is the kind of the static type version of the language. So what should we do? What should Ruby community do? Adding type annotations like PHP or Python? Yeah, they are great language. They are more popular than Ruby. Adding type annotation? What do you think? No. I had type annotations too. Because it's not dry. Your Ruby program currently run without any type notation, so that it's not fundamentally needed. You know, it's there to find more bugs earlier, so that yeah, we don't make compromise here, so that because it's not needed, Ruby programs run without type annotations, so it's not really needed. So that we have a plan for Ruby3. We are going to introduce the components to support the static typing in Ruby3, which are these. The first one is the type definition syntax. The second one is the type definitions for libraries. The third one is type profiler to generate the RB files. And the third one is the static type checkers. Type definition syntax is the separate file that contains the type information of your Ruby program or the Ruby programs. The separate file that describes types. That describes the argument types, return value types, the class and module, and the interface, which describes the kind of dark typing. I have to prepare the RBI file here, but I have no time. I didn't have the internet connection during the flight, so that yeah. Okay, I will tell you later. I'm sorry. So that we are going to the type description file compiler, which generates the type database for your compilation. Then we are going to prepare the type definition for standard libraries and some major gems. And then we are also going to add a way to add the type definition for your gems. Standard libraries, gems to be defined. Then we are going to add a type profiler. Type profiler is rely on the technique, which is called the abstract interpretation, which is the kind of the in between the runtime check and the static check. For example, okay, we have the method definition foo, which takes one argument, and then the +2 of that argument. Then we call foo here with the argument of the 15. The foo is called with the integer, so that we have the information. Foo is called with integer, and the integer hash. Integer has plus method, and which is okay. That kind of things. So find conflict with the type definitions, so that you can find the type errors by abstract interpretation. At the same time, we can generate the type description of the method foo here by using the information of the invocation call ground. So the type profiler can generate the RBI file for your program. And then if we don't claim that the type description generated by type profiler is not the complete nor sufficient for your type checking. So you can refine them if you want. So by having those type information of your program in the separate files, so you can run the more decent static type checkers. For example, the Solvet from Stripe. We are working with the Solvet team from Stripe, so that we can share those kind of type description file and type description information with those type checkers. And then we also the member of the community also worked the different type checker named Steve. Then use those type checkers use the RBI type definitions, and then that has a different characteristics. For example, Solvet is written in C++ and pretty fast, and mostly real-time check. And the Solvet type checking is mostly nominal. and it supports type annotation DSLs as well. And the STEEP is some kind of the experimental project and written in Ruby, and it uses the structural typing. And by the nature of written in Ruby, so that it is more flexible. So we may also provide the YAR to RBI converter so that you write the YAR documentation in your comments, so that you can generate the type description information out of those YAR documentation. So what will happen with them? Your ordinary Ruby program will be statically type checked. Wouldn't be that nice without any type annotations. If you refine type definition files, you will have the better type checking. Wouldn't that be cool? So we are working on it, and the result is promising for me at least. Remember, the goal of Ruby is to make programmer happy. So we will do everything to make you happy. Performance improvement, yes, we'll do our best. Better concurrency support, yes, we will do our best. Keeping compatibility, yeah, we'll do our best. Compatibility matters because we keep compatibility because the breakage is like a punishment. By upgrading Ruby to 6 to 3.0, your programs cause errors. It's kind of punishment, unless we have clear benefit. Yeah, we are not going to punish without fault in your site. So those things we will not change in Ruby 3.0. We are discussing long time for long discussion. We had long discussion for frozen string literals, which is kind of nice. But the breakage caused by these frozen string literals is not acceptable, for at least for Ruby 3. So that we just gave up. So that probably in for future. We are trying to obsolete the question mark literals for represent the characters. So we just gave up. And we try to obsolete the backquotes, which is kind of neat, but kind of low level. So we tried, but we gave up. So because we are trying to make Ruby even better, so we are going to add new features. Yes, new features. We are going to improve the keyword arguments. Yeah, I have to confess that I regret some part of the keyword arguments. It's kind of confusing. For example, like this. M takes 2 arguments, which one is the argument, the positional argument, the other is the keyword arguments. Then the print those 2. If you call the method M with key column 5, what should happen? That would be this. Kind of confusing, but because right now keyword arguments are implemented by the hash object added to the end of your argument list. It is pretty primitive, and then not work well with static type. That kind of the hacky keyword arguments will not work well with the static typing. So we will revisit them. In the Ruby 3.0, we are working to reduce the backward incompatibility, but this is, I think, the only major incompatible change in Ruby 3. And then we are going to add implicit block parameters like this at 1. At 1 represents the first argument of the block. Yeah, it is ugly, but we are working on the characters, but we are going to add something. And then we are going to the pattern matching. Not regular expression. We already have them. for a long, long time. But as in functional programming language, like this. We use case and in keyword. This is current prototype. The if object is the argument, which first argument is the symbol foo, which match, and the second argument is assigned to the variable a. And if object is the argument with the single symbol element, so that it will match the second class. And if object is anything else, which matches the underscore, so the printf, that kind of things. So that we are going to add those kind of change to make Ruby even nifty. Okay, we need to survive to provide benefit to our users, Ruby users, the community, and to sustain our lives. It's okay if Ruby dies. It's okay for most of you because of that. Okay, you can change to the say Python or JavaScript or whatever, but for me, it's crucial. So Ruby survival is pretty much important for me at least, and some core committers who work full time for Ruby. And the Ruby survival is also good for you. You don't have to migrate your service. So it is good things. We have to survive. So okay, Charles doesn't code. So that we have to survive. We have to adapt the change. So that we don't have to be the most smart language. We don't have to be the fastest language. But we have to adapt the situation around us. We will keep moving forward wisely. And not only, the Ruby is not only driven by me, myself, but it's driven by community. So that the Ruby is designed here, to exist here, to make you and make us happy, and to make the world a better place. Yeah, thank you.
Yeah, so I've been putting frozen string literal true at the top of every single file.
Yeah, that won't be removed. That's okay. That's okay. Magic comment is alive. But it's not the default. Any other question there? Yes.
The implicit block thing.
Yeah. For interactive programming like IRB, Pry things, sometimes writing the block parameters, the bar things, is kind of the burden. So it is for the trial interactive sessions, not for the long-lived Ruby project. Like say the language like Ruby has the implicit argument of it. It is our trial of implementing implement it feature in Ruby.
Is there going to be pattern matching for the method definitions or just for the case statement?
Unfortunately, just for the case statement. So that you have to accept everything in argument. Then you have to dispatch in the method. Probably in the future we will improve that. Yes, there? Yes.
I was trying to take notes. You said at some point when you get to a certain level of Ruby, it's less beneficial for a Rails application as far as speed-wise. I'm upgrading Ruby right now. I just want to know which one should I grade up to in the Rails app before it's less good.
Basically, the latest one is the better. So the current, right now, the Ruby 2.6 is the best Ruby. Any other questions? Yes.
What's the one part of Ruby you are most proud of?
I don't know, the community. You know, when I attend the conferences like this, so that so many people come up to me and say, shake hands and okay, thank you for Ruby for making my career better or making my programming fun again or something like that. That is my honor. Yep.